What paper are we covering today? And guys, marks for nothing, all right? Marks for just knowing simple steps, simple calculations. This is the place where you're really going to claw back those marks that you're not sure of, and maybe number patterns, or maybe you're not sure about counting principle, or whatever it is. This is really the place where you can score your marks back again by just following the steps. All right, so make sure that you know what you're doing here. Make sure that you cover your steps, and that you go through them carefully. Okay. All right. So first of all, if I'm looking at the cubic function, the general equation for a cubic function is f of x is equal to ax to the power of 3 plus bx to the power of 2 plus cx plus d. That's the general equation, also sometimes known as the standard equation as well. Your teachers, you might have heard them say that before, but that is the equation that we're looking at. And once again, the coefficient of the first term, or a, plays quite an important role here, in that it's going to tell us whether our graph is going to be positive, so sloping upwards, or negative, sloping downwards. So we can see that this graph, if we were starting at this point over here where my arrow is pointing, it's going up, hitting an inflection point, then going down, but finishing off, hitting a turning point, and then going up again. Whereas this graph, where a is negative, the graph is starting by going down like a negative gradient, hitting a turning point, going slightly up, hitting a turning point, and coming down again. Okay. So let's get stuck in tonight. Let's go through what we're going to be doing, and let's start with our first example. So the first example we have says solve for x in the following equation. 2x to the power of 3 plus 5x squared is equal to 3x. I'm going to give you a few seconds to try that. Okay, I'm going to give you a few seconds to try that. Solving an equation, algebra, a little bit of one. We're all good. We know how to do this. Go give that a try. Go give that a try for me. Okay. All right, grade 12s. That was a really nice, easy one. I'm sorry to say I still can't get the screen working. I'm going to keep trying throughout the whole lesson. Okay, but let's go do it. And I'm going to write it. I'm going to use it during text. So I'm going to do it using text. I'm going to just make my text a bit bigger so that you can see it. All right, so if I bring everything across to the other side, because that's what I do when I'm solving equations that have x with an exponent that's greater than 1, I'm going to have 2x to the power of 3 plus 5x to the power of 2. And I'm going to bring that one across. I'm going to have minus 3x. I'm going to say equal to 0. So I hope you got that, first of all. Okay, so that's step 1. All right. Step 2, I'm looking for a common factor. And if I'm looking at this, I'm pulling my common factor out as x. So x is my common factor, and I'm going to be left with 2x to the power of 2 plus 5x minus 3. Okay. All right. And all of that is equal to 0. Now that I've done that, my life becomes a little bit easier because I've got x, open brackets. I know I'm going to have 2 brackets. I know in the one, my first factor is 2x. I know in the other one, my other factor is going to be x. And that's all going to be equal to 0. 2x times by x gives me 2x squared. I need to have -3 on the end, which means I need to have a negative times a positive. Okay, but it's really important that I get these right. So I've got to have 5x in the middle. So what does that mean? That means I can have 2x times by 3 is going to give me 6. So in other words, I need to have positive 3 here. Okay, and I'm going to need to have -1 over here. All right, so what are my final values for x? I hope that you got x is equal to 0 or and whatever it is that you've learned, or x is equal to 1 over 2, a half. Oh, 1 over 2, or x is equal to -3. All right. Okay. Anyone who has a question about that? Are we all good? Can we move on? No questions? Nobody needs any assistance? Right. Moving on to our next one. Okay. Thank you, Lorato. Right. Moving on to your next one, guys. Have a look at that next one for me, please. I've got x to the power of 3 minus 12x is equal to -16. Okay, have a look. Have a look, see what you think. All right, have a look, see what you think. Thought maybe I had got the screen working. Okay. Oh, it's Zoom. Okay, yes. You can talk. Talk to me. There's only a few of us. Guys, if you've got a question, please just talk. Let me know. Okay, so this one is a little bit trickier. Why is this one a little bit trickier? Because now I've got -16 on that side. Okay, so it does make it a little bit trickier. I'm not going to lie to you. It really does. So what are we going to say? We're going to go do the following. Okay, we're going to have, I'm just going to make my writing a bit bigger here so you can see it nicely. I'm going to still have the same thing where I've got x to the power of 3. Okay. X to the power of 3 minus 12x, okay? And I'm going to bring that across, and I've got plus 16. All right? And that's going to be equal to 0, hey? Happy with that? Awesome. All right. Now, what would my next step be? What would my next step be? Okay, what would my next step be? Well, now my next step, if you are doing add math, then you know how to do this in add maths, but we don't all do add math, so we're not going to try and do fancy things here. We're going to go say to ourselves, okay, We're going to go try substitute in some values for our first x, okay? So first of all, we're going to go try do x is equal to 1. So we start with 1. So 1 to the power of 3 gives me 1, minus 12 times by 1 gives me 12. So 1 minus 12 is negative 11. Plus 16 gives me 5. All right. Is 1 one of the solutions for x? All right. So now we're going to go up to 2. Let's go up to 2. Okay. Thanks, Lorato. Let's go up to 2. So 2, so open brackets, 2 to the power of 3 minus 12, open brackets, times 2, plus 16 equals what on your calculator? What does it give you when you do that? What do you notice? It should give you 0, hey? So that means that we know in our 1 brackets, we're going to have x minus 2. Okay. Now we need to work out what else do we need to have. So that's my 1 bracket. Okay, I've got x minus 2 because I knew that 2 was a factor for this equation. Guys, you can carry on going and you can try and see what works. You could try see now, okay, so 2 worked, cool. What about 3? Will 3 work? And you try and put 3 in. All right, cool. And then you go, so you can do it that way, or you can say to yourself, okay, ma'am, please just quickly. Kabo, what do you want me to explain it again? Kabo, I'm not sure what you mean. Ma'am, please just quickly. You say, please just explain it again quickly. Is that what you mean? All right. So what we're doing, Kabo, is we're trying to, yes, okay, cool. We're trying to work out x factors because we couldn't factorize that. We don't know how to factorize that unless you're doing fancy add maths, and we're not doing fancy add maths here. Okay. So what did we go and do? We tried to see if x equals 1. We tried to see if 1 was a factor. 1 wasn't a factor, hey? So we moved up to 2. On our calculators, we said, open brackets, 2 to the power of 3 minus 12, open brackets, 2, close brackets, plus 16 equals. And we got 0, which means, is 2 a factor? Yes, it is. 2 is a factor. Now, guys, the good news about this is that they don't give you this kind of thing in your final exam. If they do give it to you, they're really being nasty, okay? They're really trying to be the worst. All right. But if they do give it to you, you know they're going to start with a nice easy one, either x minus 1 or x minus 2 as one of your factors, okay? All right, so now we need to work out what our other bracket is. Kabo, I hope that that made sense. Okay, now we need to work out what our other bracket is, okay? We're going to say, well, x times by what gives me x to the 3? X times by x to the 2, hey? I know I'm going to have a middle term, but I'm going to ignore it for now. I'm going to ignore it for now, okay? Because somehow, guys, when I go and multiply this out, I'm going to have x times by x to the 2 gives me x to the 3. Amazing. Then I'm going to have negative 2x squared. Do we see an x squared anywhere here? No, so it's a bit of a problem. So we need to work out how to get rid of that. We're going to do that a little bit later on. Don't stress. Okay. Negative 2 times by what gives me 16? Negative 2 times by what gives me 16? Negative 2 times by negative 8 gives me 16, hey? Okay. All right, cool, good. I like that I'm getting so many thumbs up. Amazing. Thank you, guys. So let's go work out what I've got so far. I've got x times x squared. And I'm going to go try do my workings over here. Guys, please excuse my handwritten notes. Unfortunately, I cannot get my screen to work tonight for some strange reason. So I'm going to go scribble my notes over here. X times by x squared gives me x to the 3 so far. Okay. X so far I've got times by negative 8 gives me negative 8x. Okay. Negative 2 times by x squared gives me negative 2x squared. And negative 2 times by negative 8 gives me 16. Hey, so that we were fine with. 16. Right. So I got a problem here because I need to get rid of what? I need to get rid of this. Okay, not only do I need to get rid of that, but what's my middle term here? It's negative 12x. And what's this at the moment? It's sitting at negative 8x. So I need to minus another 4x. Do you agree? All right. So in order to do that, sorry, guys, and it's this one here that I'm talking about. Apologies. So I need to get rid of that. So we're looking to get that. Okay. For another 4x here. Okay, so if I want to do that, is it fair to say that x squared times x squared will give me x to the 3? X times by what will give me another negative 4x that I need? Okay, and x times by what will give me the other positive 2x squared. So x times by what will give me 2x squared? X times by 2. Oh, x, I ran out of space. 2x. Let's check if it works the other way. X times by 2x gives me 2x squared. Amazing, because I wanted that, right? And x times by negative 8 gives us negative 8. X, cool. Then negative 2 times x squared gives 2x squared, right? So that and that have now gotten rid of each other. Negative 2 times by 4x gives me, negative 2 times by 4x gives me negative 4x. So yay, I've now got that. Okay. And this whole thing needs to be equal to 0. All right. So in my one bracket now, I've got x minus 2. Okay. Can I factorize this one as well? In my one bracket, I'm going to have x. I know I need to have a negative in the end, so I'm going to have a plus. And in this bracket, I'm going to have times by x. I know I have to have a negative in the end, so times by a negative is equal to 0. Right. What are the factors of 8? Okay, what are the factors of 8 that will leave me, okay, with positive 2x in the middle? What are the factors of 8 that will leave me with positive 2x in the middle? Well, factors of 8, 1 and 8, not going to help me. 2 and 4. Will 2 and 4 help me? Yes, they will, hey? So I'm going to have 4x minus 2. Okay, awesome. Thank you, Lorato. Well done. All right, so therefore, what do we know? Therefore, we know that x equals 2, and you can say, or x equals negative 4. Guys, can I also put there, or x equals 2? I can, but am I doing the same thing? Because have I already not got that x is equal to 2? And if I go write it twice, my marker might get upset with me. So I'm happy to just say, oh, look at that, x equals 2, or x equals negative 4. Done. Okay. All right. Right. And give you 2. Oh, no, there we go. Looks like she's missing some notes here, but it's okay. We'll go through here too. So, there we go. Okay, there we go, Teacher Sam. Okay, so Teacher Sam says, when you are sketching the cubic graph, there's some steps that you have to follow. All right. I like following steps in maths. I think that it just makes maths make sense. So step 1, find the y-intercept. Guys, you've been doing this since you first started with functions in grade 9. And if you do all your functions this way, you'll get 100%. So step 1, find the y-intercept. To find the y-intercept, we make x equal to 0. Step 2, find the x-intercept, let y equal to 0. Okay, so Teacher Sam then says there, find a factor and factorize. All right. Note, if the two intercepts are the same, it means that the graph is turning on the axis. It is an intercept and a turning point. We'll have a look at what that looks like. All right. Step 3, find your turning points, the stationary points. So what do we know about stationary points? We know that if we are looking for the derivative, which is what you've been doing during this whole thing of calculus with teacher Sam, okay? When you're doing calculus, you're looking for the derivative. Well, in functions, when you're looking for the derivative, you're actually looking for the gradient of the equation. So you go and you look for the derivative of this equation. Cool. Derivative means gradient, all right? You want to know for the turning point, also known as a stationary point, where is the derivative, the gradient, equal to 0? Because where the derivative is equal to 0, what do we know? We know that that turning point, it's neither going to be going up or going down. That graph is going to be sitting solid. Okay, it's going to be sitting in 1 point. So let the derivative equal to 0. Solve for the x. Substitute the x's into the original equation to find the corresponding y values. Then we need to go back to our original a and work out whether the graph is positive or negative. Okay. If they ask us what the points of inflection are, okay, then we will use a second derivative to determine this. But if they don't ask us, we're going to move on. Okay. If we're looking at this graph over here that teacher Sam has put for us, first of all, what do we know about this graph? First of all, what do we know about this graph? Is A going to be positive or A going to be negative? So picture this in your mind quickly. I'm going to go up to those notes that she had. When A is positive, the graph is sloping upwards. When A is negative, the graph is sloping downwards. Let's go here. This graph that she's got, is A positive or is A negative, guys? Good. A is going to be negative because the graph is coming downwards like that. All right. So at this point over here, when we're looking at the gradient, which is the derivative for this line, what do we know about the gradient of this line? Well, it's simple functions now. When a gradient is going that way, we know that the gradient is going to be negative. Okay, so the gradient is negative. What do we hit here? We hit a turning point. And what do we know about this turning point? By looking at the drawing, we see that this is a minimum turning point because it's at the bottom. So there's my turning point. All right. What can we say about this as well? We can say that it's concave up. So the graph is concave up. We're now moving along this line over here. And what can we see about this line? Well, if we look at our normal functions, when our graph is sitting like this, what do we know? We know that the gradient is positive. In other words, the derivative or the gradient is positive. At our maximum point over here, what do we see? We see that the gradient is equal to 0 and the graph is concave down. And again, towards the end of the graph, what do we know? We know that the gradient is negative. So teachers say, in order to determine the point of, and then so method 1, find the derivative of the derivative, the double derivative, always fun. Method 2, determine the midpoint of the two turning points. So you can use either method. And then determine the y value of the point of inflection. Substitute the x found in step 1 into the original equation. Okay, and then you sketch a graph now. Okay, so when they ask us to sketch a graph, when they ask you to sketch a graph, grade 12, it does not mean that you do not use a ruler. So you bring a ruler across. Okay, hopefully it lets me move the ruler. Yeah. Okay, you're going to bring your ruler across and we're going to sketch a set of axes. All right. Apologies, this ruler is doing its most tonight. Okay, in the last class, I couldn't get rid of it at one point. Okay, let's see if it'll, please let us just adjust you. All right, so you bring your ruler across. If you can eventually get it to work, then you get your ruler to work, and you use your ruler and a pen to draw a rough sketch. Okay, it says sketch the graph, sketch the graph. You still use a ruler. Apologies, mine is not very straight, but you draw an x-axis and you draw a y-axis, right? And you label it straight away, x, and you label it straight away, y. Grade 12s, this is an important step. Okay, because sometimes the grade 12s, they do all the working out and then you forget to actually sketch the graph. So go draw your graph first. There's my graph. Right, now I'm going to go do my calculations. So I'm going to write them because it just is easier and you guys can see it a bit better. Okay, teacher Sam said, what's step one? Step one is find the y-intercept. Okay, to find the y-intercept, what do we know we need to do? We need to make what? To find the y-intercept, guys, how do you find y-intercept? You make x equal to 0. All right, so good. So f of x is the same thing as saying y. All right, so I'm going to say y equals, or you can write f of x if you really want to. It's not a train smash. Y equals, all right, open brackets, 0 to the power of 3 minus 6, 0 to the power of 2 plus 9 times 0. Okay, when I do that, I see that y is equal to 0. So what's my y-intercept? My y-intercept is the point. 0 is to 0. So go and draw that on your graph straight away. So I go draw that on my graph. I'm going to draw it in blue so you can see it. It's at the origin. And I'm going to label that point anyway. I know I'm being extra, but I want to make sure that I get my full marks here. So 0 is to 0. All right, it's back here. Okay. Step 2, get your x-intercepts. Make y equal to 0, okay? Good, make y equal to 0. So I've got 0 is equal to x to the power of 3 minus 6, x to the power of 2, okay, plus 9x. All right, guys, what can I see straight away, grade 12s? Straight away, I can see, take out a common factor. What's your common factor? It's x. And I'm left with x to the power of 2 minus 6x, okay, plus 9. All right, go factorize that for me, please. Go factorize that for me, please, while I make this a bit bigger. Go factorize that. You got this. Okay, go factorize that. So you should have x, open brackets, x minus 3, and x minus 3. So, therefore, x equals 0, or x equals 3. Can I write or x equals 3 again? I could, but is it redundant? Does it mean the same thing? Yes, it means the same thing, so we don't want to be redundant here. Okay, so we need it to be, so my 2 pointing points are going to be x, sorry, my 2 x-intercepts, 0 is to 0, or 3 is to 0. Okay, so 0 is to 0, I already got that. Let's go put 3 is to 0 on here. 3 is to 0, making sure, even if I don't get time to finish this, I'm at least getting my marks for everything I've drawn on my graph. Okay, step 3. Step 3, find your turning points. Turning points or stationary points, whatever you want to call them. What do you need to do first? You need to find your derivative. So the derivative of f of x is going to be equal to what? I'm going to have 3x squared, okay, minus 12x plus 9. Right. Everyone happy with how I got the derivative? Everybody agree with me? Everyone good? Okay, cool. I see Lorato with a thumbs up, so that's cool. Anyone else? No, all good? Okay. Nakubonga, you've raised your hand. Do you have a question you can ask? Anyone with a question? Are we all good? Okay, maybe it was a mistake. All right, okay, cool. Okay, so now we're going to make our derivative equal to 0. So 0 equals, and guys, while I'm at it, I'm just going to go and take out my common factor here. So I see a common factor of 3. So, and then I know I'm going to have 2 brackets, but I'm going to do that step by step. So x to the power of 2 minus 4x plus 3. Okay? All right. So I've got 0 equals 3, open brackets, x minus 3, and x minus 1. Okay, I factorized it, and that's what I got when I factorized. So therefore I have x equals 3 or x equals 1. Okay, but is that my turning point? Is that my turning point? No, it is not my turning point. And this again is where some of our grade 12s go and make a fatal error. Why am I saying a fatal error? Because what happens is you get all excited. Okay, I'm going to go take this and put this into my derivative. No. How do you get your turning point? You take that and you put it into your original equation. So your original equation was y is equal to, okay, x to the power of 3. So y equals x, which is now 3, to the power of 3. Okay. Then my original equation, minus 6. So minus 6 x, which is now 3, to the power of 2. Okay. My original equation, plus 9, open brackets, times by 3. Or it's going to be exactly the same, but instead of seeing 3, what are we going to see instead? We're going to see 1. Okay. So for my first one, where I had that x was equal to 3 in my derivative, what do I get for my y value, please? What do I get for my y value for that first one? What do I get for my y value? Put it into your calculators. What do you get? Okay, make sure you're calculating correctly. Make sure you're calculating correctly. All right. Good. Thank you, Lorato. You get 0. So when you calculate it and you've calculated it correctly, you get y equals 0. Or what do you get for the second one? Y is equal to what? You get y equals 4. Hey? So my turning points are going to be 3 is to 0. Or 1 is to 4. So let's go. Going back to my graph. Okay, I've already got my one turning point labeled as 3 is to 0. I need to draw my other turning point as 1 is to 4. So I'm going to say it's about there. Label it. 1 is to 4. All right, what's left to do? I need to draw my graph. I know that A was positive in this case. So what does that mean? It means I'm going from the bottom. This was an intercept. Intercept means it's going through, turning at 1:4 because it's stationary, down to 3:1. What do we know about 3:1? It's also a turning point. So turning at 3:1 and going up again. Arrow and an arrow. And grade 12, you want to get that final mark. So we're going to say f of x. Okay. When you're doing interpreting graphs with teacher Sam, she's going to teach you how to do points of inflection. I want us to practice more on drawing these graphs. All right. Everyone got this as a screenshot? You got the calculations? Are we all good? Awesome. All right. Let's move on to the next one. The next one says, sketch the graph. So I stop. I don't even move on when I read sketch the graph. I go draw a graph first. To remind myself, I need to have a graph. Ruler and a pencil, please. Make sure you're using a ruler. Label Y, label X. Done. I've sketched my graph. Okay, now I can go back and do my equation. All right, so sketch the graph of g of x is equal to x to the power of 3 minus 12x plus 36. All right, step one. Step one, find the y-intercept. To find the y-intercept, what do I need to do? I need to make x equal to 0. So step one, y-intercepts, make x equal to 0. All right, so I'm going to have y, or I can say g of x if I really want to, means the same thing, okay, is equal to, open brackets, 0 to the power of 3 minus 12, 0 to the power of 2 plus 36 times 0. Okay, put that in your calculator, and what do you notice? You will notice that y is equal to 0. So what do we know about our y-intercept? It's the point. 0 is to 0. Okay, good. Nice, guys. So I come straight to my graph, and I'm going to draw that. 0 is to 0. I'm going to label it. 0 is to 0. Okay. All right. Step 2. What's step 2? Step 2 is find the x-intercept. Hey, step 2, x-intercept. To get the x-intercept, I must make y equal to 0. All right. So I'm going to have 0 is equal to, can I throw a step in between here? What can I see already about this? I can take out a common factor. Hey, are you happy with that? I'm going to take out a common factor of x. And I'll be left with x to the power of 2 minus 12x plus 36. All right. Now I'm going to factorize. So I've got 0 equals leaving x on the outside, open brackets. I know I need to have x. I need to have a negative in the center, but a positive at the end. So it's going to be a negative. So x needs to be a negative. All right, factors of 36, 1 and 36, nope. 2 and 18, nope. 3 and 12, nope. 4 and 8, does 4 and 8 work? No, I'm lying to you. 4 and 9, what am I saying? 4 and 9, nope. So Lorato, thank you. 6 and 6. Okay, 6. And like Lorato says, 6. So therefore, I've got x equals 0. X equals 6. Is this the same case again where I've got 6 and 6, guys? It is, hey? So my points are going to be 0 is to 0. Or 6 is 0. Let's go label 6 as to 0. So here we go. I'm going to put it right at the end. Open up my brackets. 6 is to 0. Okay, so far I've got 2, maybe 3 marks already. Okay. Coming back. Right, step 3, find the turning points, hey? Turning points. All right, to find the turning points, what do I need to do? I need to go work out the derivative. So the derivative of thank you, of g of x is equal to what? It's equal to 3x squared minus 24x plus 36. All right. If I'm looking for turning points, I've calculated derivative. What's another word for derivative? Another word for derivative is what? What's another word for derivative, guys? I told you earlier on. Another word for derivative is the? What is another word for derivative? Come on, you got this. What's another word for derivative? It's the? Inflection, okay, no, inflection's weird things. It's the gradient, hey? I know you heard me saying inflection a lot, Lorato, thanks. But it's the gradient, okay? Thank you for participating with me, so I know I'm not by myself. Okay, so the derivative is known as the gradient in this case. So I want to make my gradient equal to 0 because that's where I know where it's going to turn. So I'm going to take 3 out as a common factor. I'm going to have x squared minus 8x plus 12, right? 0 equals, I'll leave 3 there for now. It doesn't really affect me another way. Anyway, x, and I'm going to say here what? X, what are the factors of 12? 6, so I've got minus 6 and x minus 2. So therefore, x equals 6 or x equals 2. Now be careful, grade 12s. Be careful. What do grade 12s often go and do? They often go and put this into the derivative. No, it needs to go into the original equation. So I'm going to get y is going to be equal to, right, my original equation was x cubed. So open brackets, 6 to the power of 3, right, minus, it was 12x, which is now 6 to the power of 2, plus 36, open brackets, 6. Or I'm going to say all of this, but instead of 6, I'm going to put in 2 here. Right, what do I get? What do I get? Y equals what when you put that in your first one into your calculators? What do you get when you put that first one in? What do you get? 0. Good. Nice. Well done. So when you put the first one in, you get y equals 0. Or y equals what for the second one? Good, Lorato. Thank you. 32. So my turning points are going to be the points. 6 is to 0. Or an and, or whatever you want to say. 2 is to 32. Let's go draw those in. So I already have 6 is to 0. I need 2 is to 32. So 2 is to 32, it's not as to scale, so whatever. 2, thank goodness it's not as to scale, otherwise we'd be here all day, is to 32. Okay. We know that this is a positive graph, so we are going from the bottom through the intercepts of y and x, up, hitting my turning points, coming down to my other intercept. My other intercept is also a turning point. So hitting my turning points, moving up again, arrow, and an arrow. Last thing to do, we're going to label it G of X. Okay, make sure you've got that in a screenshot. Make sure you've got that in a screenshot. Grade 12s, while you're taking this in a screenshot, there is a teacher that I've been following on TikTok and Instagram, and she really helps with things like making a study timetable. So one of the things she's got pinned on her social media is how to make a really, really good grade 12 study timetable. So if you aren't following her already, go and have a look at Miss Angler. Okay, so if you don't already have Miss Angler and you're not following her on TikTok or Instagram, go do it later today. If you have data or you have Wi-Fi or whatever it is, go find Miss Angler. She's a teacher. She also does study guides for different subjects. But the thing that I'm suggesting that you go and follow on hers or go have a watch is how to make a really good study timetable or revision timetable if you're not sure of how to do that yet. Okay, go and have a look at Miss Angler. All right. If you already follow her, amazing. Then you know about the study timetable I'm talking about. It's really cool. Works really, really well. Very effective. Okay. All right. Now we've got a negative graph. Okay. Now we've got a negative graph. All right. So we've got a negative graph. They've given us a function. They've asked us to sketch the function. Yo, guys, we're not going to have enough time to do this, but what I'd like you to do is I'd like you to take some screenshots of what they look like. So take a screenshot, okay, of this question. I'm going to move down to the next question for you so you can take a screenshot of that as well, okay? I'm going to take a screenshot. I'm going to move it down so you can take a screenshot of the next one so that you can go and practice. Then on Wednesday next lesson. On Wednesday, our teacher Sam, if you're not sure, you can ask her to sketch them with you. Okay, so have a look at those functions, okay? All right, have a look, take a screenshot of that one. All right. It's a nice one. It's a negative one. So what do we know? We know that the A value is negative, so it's going to be sloping downwards this time. Okay. All right, I'm going to go to the next one for you. Oh, Teacher Sam's already put all the answers in this one for you. Oh, my goodness. Teacher Sam has been very kind here for you. Okay, so Teacher Sam has put the answers in for this one here for you. That's very kind of her. So again, take a screenshot of the next one as well. It's the now you try one. So go take a screenshot of that one. In this one, she's even done the points of inflection for you. All right. And I think that that's her last one for you for the night. Yes. Okay. All right. I am going to give you some of the calculations for this one quickly so that you can check your answers and make sure that you're good. So first of all, we know that this is a negative graph because A is less than 0. So we know the graph is going to slope this away, kind of, hey? Okay, something like that, like a negative graph. All right, however you want to do it, but it's going to be negative. Okay, then what do we need to do? We need to find the y-intercept and the x-intercept, hey? So I'm going to go say here to myself, I know what the y-intercept is because they've been quite kind to me. They've left it off this time. Y is equal to 18 here. All right. I'm going to go and I'm going to say I'm going to ignore x-intercepts for now because for me, I don't like it when I've got to go and try and solve this and put things in. And so for now, before I start to find those points, I'm going to go first calculate what my what my turning points are, because I think that's a little bit easier to do. So in order to calculate my turning points, what do I need to go and do? I need to go and find the derivative, hey? And when I find the derivative, all right, you'll see that you actually get fractions for the derivative. You actually get fractions for the derivative. So I'm going to put my screenshots in here for you of what I've got for my derivative. Okay. All right. And when you see that you've got fractions or like you've got a strange one, you can actually use, I like to use it all the time for nearly everything I do. I like to use the quadratic formula. I just know that I'm doing it correctly when I use the quadratic formula. So I'm going to input how you get the turning points here. Oh, and of course it's going to move all over the place because tonight we have not had it easy here. So see if it'll let me move them. Okay, so the next step would be to get the turning points. Right, I'm going to make it bigger. Okay, they call it critical points here, but it's the same thing as saying the turning points. Okay, so take a screenshot of that one as well so that you've got it. Right. You would then input that back into your equation, and for this one, you get y is equal to, let me calculate it quickly. You'll get y is equal to 0, or you get y is equal to, when you put it back into your original equation, you get y is equal to, apologies, you get y is equal to, I get 18,52, but that's just because I've done it on my calculator on my computer, but you'll get a fraction. All right, so that's just giving you some of the calculations to set you off on the right path. I would suggest go try the question, okay? Make sure that you've got it, and then if you're not sure, ask Teacher Sam. Okay, so Letabo is saying that Miss Angler is very good even in her study guides. I agree with you, Letabo, and they're quite affordable as well. She does biology, she does science. I think she might have a maths one, but I don't think grade 12 yet. Okay, will the d value always be the y-intercept, and should they give us one in the equation? Lorato, yes, you know that that last value that doesn't have any coefficient is normally what? It's normally your y-intercept. Also, if you make x equal to 0, what do you know about this equation? Let's go all the way back here. Let's see if it'll let us look at it. Okay, what do you know? You know that, all right, if you had to make x equal to 0 for that equation, what are you going to see? You're going to see, okay, you're going to see that once you make x equal to 0, well, you're going to have 0 to the power of 3 minus 4, 0 to the power of 2 plus 3 times 0. You're going to be left with 18. Okay. Will they always give you one in the equation? No, the previous two that we didn't. What was the y-intercept? It was 0, because what was the d value? The d value was 0. I hope that that makes sense. All right, guys, if you're not sure, I'm going to message Teacher Sam as well and just say that we didn't get to do example 5. So if she can just go over with that with you again. Okay, otherwise, have a beautiful evening. If I don't see you before trials, even though I said that to you the last time,